Hello everyone. Hopefully you can all hear me. My name is Spencer Allingham, and I'm the Regional Vice President at Conducive for Europe, the Middle East, and Africa. Now, hopefully you haven't just heard my title and thought, "Oh no, I'm going to jump off because this is going to be a sales and marketing thing." I've actually been the technical director at Conducive for the last 7 years until my recent promotion. And I'd like to conduct this, where possible, as an engineer rather than just another sales guy. So to that end, I should be able to answer any questions that you guys want to throw at me. So I invite you rather to use that Q&A box in the WebEx window. If you have any questions as we're going through, please do feel free to put them into that Q&A box. There's no such thing, in my opinion, as a stupid question. If you have a question, chances are somebody else is sitting there with the same question. So feel free to put it in that Q&A box, and I will do my very best to answer as many as I can in the Q&A session at the end. So today's presentation is sponsored by Conducive, of course, and I'd like to take the opportunity to introduce you to the Velocity software that you can use to speed up your SQL servers and other workload types too, other types of databases or busy file servers and so on, without having to reboot any of your machines and without any SQL code changes being necessary. It's software that you just install and go. It's really that simple. So to illustrate why you might want to consider downloading and installing the Velocity software onto your SQL servers, I actually ran some lab tests using HammerDB to generate an online transaction processing type workload with and without Velocity installed. Firstly, using SSD storage, and then using spinning disk storage. And as you can see from the metrics recorded by HammerDB, on the SSD storage, there was about a 30% improvement in the number of SQL transactions that could be processed per minute. And this was backed up by the perfmon metrics that showed a 28% improvement in transactions per second. When running the tests again using spinning hard drive storage, there was around 100% improvement. Now, either way, this is great news for SQL DBAs who care about the performance of the databases underpinning their business-critical applications. Whether you're running SQL in a physical or virtualized environment, most SQL DBAs would welcome faster storage at a reasonable price. And Conducive's Velocity software is designed to provide exactly that, but using the storage hardware that you already own. It doesn't matter if you have direct attached disks, if you're running a tiered SAN, have a tray of SSD storage, or are fortunate enough to have an all-flash array. That storage layer can be a limiting factor to your SQL database's productivity. The Velocity software reduces the amount of storage I/O traffic that has to go out and be processed by the disk storage layer, and it streamlines or optimizes the data which does still have to go out to disk. And the net result is simply that SQL can get more transactions completed in the same amount of time, quite simply because on average it's not having to wait so much on the storage layer before being able to get on with its next transaction. Velocity can be downloaded and installed without any disruption to live SQL servers. No SQL code changes are required and no reboots. Just install, and typically you'll start seeing results in just a few minutes. And before we take a more in-depth look at that, I'd like to briefly mention that last year, the Velocity software was awarded the Microsoft SQL Server I/O Reliability Certification, which is quite a mouthful. But basically, that means that whilst providing faster storage access, Velocity didn't adversely affect the required and recommended behaviors that an I/O subsystem must provide for SQL, as defined by Microsoft themselves. Now, most SQL DBAs are familiar with why split pages are bad for performance. If you've got room and your update or insert doesn't require a split, Well, this is pretty fast because SQL is just updating one page and then writing it out to disk and, of course, to the transaction log. But if the updated or inserted row doesn't fit, SQL needs to allocate a new page, move about half of the rows to the new page, and then write both pages to disk and to the transaction log. In addition, the pages in all the indexes that point to the data pages, well, they need to be updated too. So let's say that your table had one clustered index and 4 non-clustered indexes. That would mean at least 7 pages would need to be updated. You'd have 1 for the clustered index structure, 4 for the non-clustered indexes, and 2 in the data pages in the clustered index. So this page split would result in a minimum of 7 times the I/O as an insert or update that didn't require a page split. Each I/O that takes place takes a measurable amount of time and resource to process. And the same is true when the Windows file system splits data as it writes out to the logical NTFS volume. And that can have significant performance ramifications too. And this is basically why SQL DBAs format volumes to be used by SQL with a 64K cluster size, rather than just leaving the NTFS default of 4 kilobytes. It helps to avoid split I/O situations when writing to disk, and it keeps performance losing or performance draining file fragmentation from building up so quickly. But it doesn't actually completely fix the problem though. As your NTFS file systems mature over time and files are created, extended, deleted, and you generally move data around that volume, the free space on the NTFS volume will become more and more fragmented into smaller and smaller free space extents, increasing those split I/O situations when writing. And each time your write is split in this way, the data is being sent out to the disk in a separate I/O packet. And like split pages in SQL, each I/O takes a measurable amount of time and resource to process. In the real world, a gigabyte of storage I/O traffic that should be written in, let's say, 2,000 or 3,000 I/Os could now be taking 30,000 or 40,000 I/Os to complete. And we call the performance penalty that these split I/O situations cause the Windows I/O tax, as in a tax on your performance because of the split I/Os. Now, in a virtualized environment, this performance penalty can be amplified by something called the I/O blender effect. And what's happening here is that you have small, fractured I/O packets coming from the virtual machines, and as they pass through the hypervisor, which could be VMware ESX or ESXi or a Hyper-V host or KVM running on Red Hat, but as they pass through the hypervisor mixes these I/O streams together, causing a randomization effect. So that then what comes out between that physical host hypervisor and the backend disk storage controller is now a chaotic mess of small, fractured, and now very randomized I/O streams that by the time they hit the storage controller, frankly, they couldn't be less storage friendly. It means that the storage controller is only receiving data in very small packets at a time, so it now only has the opportunity to create very small stripes across its media. And that means many more storage level operations than if the data hadn't been split as it was being written right at the top, right up there at the NTFS layer. Now, velocity helps Windows avoid or prevent most of the excess, unnecessary, performance-losing split I/O traffic, and replaces it with far fewer storage I/O packets, each one carrying a larger payload of data. And this makes the movement of data between server and storage quite simply more efficient, much like avoiding page splits wherever possible in SQL. And it allows the disk storage to store the data using far fewer storage level operations that are a lot more sequential in nature. Velocity will also help create those nice, large free space extents quietly and automatically in the background using only otherwise idle compute resources to make it easier for the Windows write driver to write into. So think for a moment of a busy freeway or motorway at rush hour. Imagine that you've got lots of cars and they're all sitting bumper to bumper with one person in each car, and none of them are getting anywhere very quickly. So now imagine that each car on the motorway is a storage I/O packet, and each person in each car is your data. What Velocity is basically doing is taking all of the people out of the cars and placing them in buses or coaches and removing all of the cars from the motorway, getting rid of all of that congestion, so that now all the people, or your data, can now flow to their destination in a much more efficient manner. I hope that makes sense as an analogy. But that's only really half of the story. Velocity also introduces a RAM caching technique into the Windows operating system that further reduces the read I/O traffic that the back-end storage has to deal with. The performance benefits provided are in addition to SQL's own buffering and any caching natively provided by the Windows operating system. And quite simply, this is how we could get 30% more SQL transactions done in the same amount of time during that testing that I mentioned before. Quite simply, SQL could get more work done in the same amount of time because it wasn't having to wait so much on the disk storage layer before being able to get on with its next transaction. And because, quite simply, RAM is faster than pretty much any disk storage that you are currently using. Oh, and it absolutely works with both physical and virtualized SQL servers, and in the cloud as well. So storage I/O reduction, optimization, and RAM caching represent a significant reduction in workload that has to be processed by the backend storage. And this is not only true of SQL Server's storage traffic, but in other workload types too. So in this example on the screen, let's say that the first VM is hosting SQL, and the second is hosting the application that interfaces with SQL, and the other two VMs are hosting busy file servers, and they're all sharing that same backend storage. You've got a SAN sitting there underneath. You might have a situation where the traffic from the file servers are taxing the performance of SQL by keeping the storage layer busy. So SQL itself isn't necessarily the cause of the disk storage being slow, but it would likely be affected by the increased disk I/O queue depths and latency caused by the busy workloads on the file servers. So my recommendation would be to install the Velocity software on all Windows machines that are sharing the same backend storage. That way, from the point of view of the storage, it's now quite simply doing the least amount of work, regardless of which VM is generating the most storage workload at any given time. Now, at this point, some of you might be thinking, yes, but SQL is already using most of the available memory in the machine. How can you possibly create a RAM cache? And it's true that if SQL is left uncapped, there typically wouldn't be enough RAM for conducive software to create a cache with. We've intentionally designed our software so that it can't compete for system resources with anything else that you have running on the machine, basically so that we can never be the cause of a memory starvation situation. Velocity would only use some of the free RAM that isn't being used by anything else, and it will dynamically size the cache, handing RAM back to Windows if other processes or applications need it. So, for best results, you can easily cap the amount of RAM that SQL takes for its own form of caching or buffering. On busy database servers, if you can leave 16 gigabytes of RAM free, you'd have a Velocity cache size that would be enough to really make that machine's performance fly in most cases. And if you can't spare 16 gig, leave 8 gig free. And if you can't afford 8 gig, leave 4 gig free. Even that is enough to make a difference. If you go smaller than that, though, the cache size would really be a bit too small, and the performance improvements would become fairly limited. And you might also be thinking that, well, actually, SQL's buffering is good enough. So how does Velocity's caching complement this? And at a basic level, SQL's cache does do a pretty good job. And whilst that does have a positive impact on performance, Velocity's RAM caching is designed to eliminate the type of storage I/O traffic that tends to slow the storage down the most. And whilst that tends to be the smaller, more random, noisy read I/O traffic, it's not actually always the case. So Velocity uses a very lightweight storage filter driver to gather telemetry data. And this allows the software to learn useful things like what is the main application in use on the machine, what type of files are being accessed, and what type of storage I/O streams are being generated, and at what times of the day, the week, the month, the quarter, so it can be very intelligent about what the hot blocks of data are that need to be in the RAM cache, and more importantly, when. And it can also use that telemetry to figure out how best to size the storage I/O packets to give the main application the best performance. And then if the way that you use that machine changes over time, Velocity can automatically adapt to those changes without you having to reconfigure or tweak any settings. Validating results is really easy. It really is very, very easy. First of all, you could measure the amount of SQL transactions being done each day to see if they increase. Some customers see reports that they generate take less time to produce, or SQL batch imports take less time, other batch jobs complete more quickly. Some customers have even done a simple stopwatch test to measure things like record retrieval times. However, Velocity itself comes with very transparent reporting that will show you exactly how much storage I/O traffic it's able to eliminate from having to go out to the disk storage layer. You can see what percentage of the reads and writes are being eliminated, and it will show you how much storage time is being saved by the storage not having to process that eliminated I/O. Now, if you're using thin provisioned storage, so in a virtualized environment, let's say you're using thin provisioned VMDK files or dynamic disks in Hyper-V, Velocity can also help you reclaim space by automatically zeroing out free space so that you don't have to wait for hours for an S-delete pass to complete. If you're thin provisioning down at the storage layer, let's say you have a NetApp filer or an HP 3PAR SAN or a Dell Compellent SAN, something like that, that uses thin provisioning right down there at the storage layer, Velocity can also send SCSI unmap commands down to the storage controller to notify it of blocks that are no longer needed. That also works if you're using virtual volumes in VMware or vVols, as they're properly known. If your VMs are provisioned with dynamically allocated RAM instead of a fixed amount of RAM, such that the hypervisor can borrow some RAM back to reallocate to some other VM, it's important for best results to make sure that you reserve enough RAM in your SQL VM's configuration for both SQL and Velocity. Otherwise, too much RAM in the VM could become driver locked by the hypervisor's ballooning driver, and that would mean that Velocity might not get enough RAM to cache with effectively. Now, these are just some of the case studies that you can access on our website at conducive.com. And as I mentioned at the top of the presentation, I actually am a technical engineer. I'm not a sales guy. So I'm not going to bore you by going through every single one of these and give you death by PowerPoint, because nobody wants that. But I'll pick out one example, the one on the bottom left here, Bell Mobility. They're a telecoms company in Canada, and they saw the Velocity software reduce the storage I/O traffic to their SAN by 61%. I mean, that's huge. 61% reduction in storage I/O traffic and workload down at the storage layer. This gave them SQL report queries that were 3 times faster, with no additional hardware required. all they had to do was just simply install the software, which, as I mentioned earlier, is completely non-disruptive. There are no SQL code changes required, no reboots required, and really zero disruption to live running workloads. So, in terms of next steps, firstly, I would encourage you to share what you've learned in this session with colleagues. See what they have to say about this. They might say, well, this is a great idea, or, well, how will it work with such and such? They may even be using it themselves already. But the simplest and best way to test velocity is to try it for yourself with your real-world workloads. I don't want you to take my word for any of this. I want you to put it to the test. And everyone who's attending today will receive a full copy of the software from Conducive directly, worth over $500. That's 500 US. You don't have to be in North America to get that. Even if you're in Europe, Middle East, and Africa, you'll get your full copy as well, and that's yours to keep. Make sure you follow the best practice tips that I mentioned earlier for best results, and really ensure that you leave at least 4 gig of RAM to cache with. You can also try the software on all of your machines at once using the 30-day trialware version, and you can download that right now from conducive.com/try. That link is there at the bottom of the page. And that's really how you can see the full power of the software. Yes, you can put the NFR copy on that full copy that's yours to keep on a single SQL server, and if you want to try it on another machine, you can uninstall it and install it on the other machine. As long as you have that full copy running on just one machine at a time, that will let you play with the software, see how it works, see how non-disruptive it is, see how easy and quick it is to install, and so on. But if you really want to see the full power of the software, you want to be running it on as many Windows machines as you can that are sharing the same storage. That's really where you're going to get the most bang for buck. And that's why we have the 30-day trialware. If you have hundreds and hundreds of machines, we can also provide you with something called the Velocity Management Console that you can set up on a machine or a VM. And again, it takes 2 minutes to install. It's very quick and easy. And from there, you can deploy the Velocity software across the network to your target machines. Again, no reboots required. And you can use that console as a central point of command and control and a central point for reporting. So you can get an aggregated report from all of the machines running Velocity to see what difference it's making overall to your data center. And if you want any help setting that up, you're very welcome to reach out to me directly. My email address is here on the screen. It's srsemia@conducive.com. If you're in North America, I've included our lead solutions engineer there as well, srse1west@conducive.com. You're very welcome to reach out to us if you want any help installing the software, running a proof of concept, evaluating results. Usually what we do when we get results from a customer or a prospective customer, we will analyze it with them and write an engineer's report that will show exactly what the software has been able to achieve. It'll give you some additional analysis to just the reports that you can get out of the software. And really want to help you evaluate it and answer any questions. So if your organization would benefit from having faster storage at a reasonable price, using the storage hardware that you already own, I would urge you just simply give it a try. You're not going to disrupt any live running workloads. You don't have to make any SQL code changes, and really the whole download and install will take no more than a few minutes. Use the software to not only identify those servers that cause storage I/O performance issues, but fix those issues at the same time. So I hope that's been interesting. I'm going to see if we have any questions in the Q&A section. So let's see if I can bring that up without closing the screen off here. Okay, so yeah, we've got a few comments here. So Bendas Daniel says, Inspired comparison with the highway. Bravo. Well, thank you. I can't claim to have come up with that. It was actually one of my colleagues in the US who came up with that, and I embellished it slightly. But yeah, that always goes down quite well. I'm glad you liked it. He says, I will share all the tech news with pleasure. Fantastic. No, that's brilliant. Now, let's see. Have we got any other questions come through? Yes. Okay, here's one from Francisco. Let me expand that a little. So he says, brilliant presentation. Oh, thank you very much. I'm actually blushing, although you can't see me. Where can I download the console? If you go to conducive.com/try, you can download the console from there. That'll give you the console and the 30-day version, and you can use it with your single server license as well if you want to do that. So yeah, you can get the console from conducive.com/try and the server version that you can just install directly as well if you prefer. So he also says for dashboard monitoring of velocity. Oh, okay, so it's for dashboard monitoring of the velocity deployments. Okay, so yes, that's exactly what you want to use that management console for. If you have, let's say, a handful of machines, let's say you're a smaller organization and you've got between 5 and 20 servers, maybe virtual servers, maybe physical ones even. Probably the easiest thing to do is just get the server version of the software and just install it directly because it's so quick and easy. But if you have a greater number of machines, then it definitely is worth investing the 2 to 3 minutes installing that management console so that you can push the software out to all of the machines at once across the network. Actually, because I'm a techie, I'll let you into a secret. It actually doesn't push it out or to all of the machines at the same time because we don't want to swamp your network with traffic. It'll do it in batches. You'll create a job which will say, these are the machines I want to deploy to, and it will work down that list a few at a time. So let's say it'll start by doing 4 or 5 machines, and then when the first one is complete, it'll then start the next one in the list and so on and work its way down. The install, even on hundreds of machines, literally takes a few minutes, probably less time than it will take you to drink a cup of tea or coffee. And as I mentioned, you're very welcome to get assistance from us to do that as well. So let's see if we have any other questions that I can see. Francisco says, great, thank you. You're welcome. Sturton Mui, and forgive me if I've pronounced that wrong, Sturton. He says, hi there, any implementations with hyperconverged storage like HPE SimpliVity? Yes, absolutely. In fact, I think we've got a case study. It's certainly with a hyperconverged system. I think it was with the University of Illinois. But certainly you can reach out to myself personally to request a copy of that or one of the other commercial reps, and they can send it to you. And of course you can find it on our website as well. I think the case studies you'll see in the About Us section. And it's the University of Illinois that we're using a hyperconverged infrastructure. And the reason why it works with hyperconverged is because the software actually gets installed into the Windows operating systems that you're running. So hyperconverged, I'm sure, being a technical audience, most of you know what hyperconverged is, but just in case there's a few of you that aren't sure, hyperconverged environment is basically, at its simplest level, a data center in a box. You have your storage, your hypervisor layer, your connectivity. A lot of it is software defined, which makes it very easy to configure and maintain, but it's basically a lump of compute in a box. And then if you decide that you're outgrowing that and you need more compute, you can get another one typically and then spread the load between the two. So think of it a bit like Lego bricks. That allow you to have an amount of compute, and if you need more, you just keep adding more to what you already have to expand the level of compute fairly easily. I think hopefully that's the easiest way of describing it. If I've got that horribly wrong, feel free to comment, but I'm pretty certain that's right. So in that compute environment, in that hyperconverged environment, you have a number of Windows machines that you're running, just like on a Hyper-V server, for example. except that all of the components in that compute stack are pretty much in one box or in one rack. So you're installing the Velocity software into the guest Windows machines, whether they're a client operating system like Windows 10, Windows 8, Windows 7, or more commonly if it's Windows Server. So the software will work with Windows Server 2008 R2 and later, right up to and including Windows Server 2019. And so, yeah, it will absolutely work in that hyper-converged environment. What is the benefit, though, of doing that? Basically, what it's doing is significantly reducing the amount of storage I/O traffic that has to be dealt with by the storage layer. As a rough example, I typically see at most customer sites a reduction of somewhere between 30 to 50%. And in some cases even more. I have seen storage workload reduction of up to 70% in some extreme cases, but even 30 to 50% reduction. What that means is that your IOs per second or IOPS requirement is significantly reduced, and that extra IO headroom that you're handing back to the environment means that you can now host a greater number of machines over that same hyper-converged infrastructure than you otherwise would be able to do if the whole thing's becoming storage bound or storage traffic bound and starting to slow down. So what that means is that you could possibly defer that next capital investment in your next hardware addition or upgrade. So basically, do more work, have a greater workload capacity with the storage hardware and then the hyper-converged infrastructure that you already own. So I hope that makes sense. Sorry, it was a bit of a long-winded answer. Right, let's see. I think we've got a few more come through. Let me expand that so I can read them more easily. Oh, it's not letting me. Okay. So Ricardo says, I will share with my team and my manager to align if we test it or not. That's brilliant. That's all I can ask, Ricardo. And to help you, of course, you'll get a copy of the software afterwards, but a recording of this presentation is being made. So if you wanted to, you can share this deck and this entire presentation with them as well. And I'd be more than happy to jump on a call if they have any questions at all. Bendas says, can I share the information you provide in the recorded file to other partners? So I kind of just answered that, but the answer to that is yes, absolutely, and I welcome it. You're very welcome to share all of this with as many people as you want. And Ricardo says, but I will try to do it for sure. It seems to improve a lot. Well, yeah, absolutely. As I mentioned, I don't want you to take my word for any of this. Really, I want you to try it for yourself, because no two IT infrastructures are the same. And I'm not going to sort of stand here and say to you that this is a silver bullet for all performance issues, because that would be unrealistic of me, and I'm an engineer, not a sales guy. It's not. If you've got something like a DHCP server or a DHCP server running as a VM, that isn't generating a great deal of storage I/O traffic. And whilst there's nothing wrong with installing the software there, it's not going to set the world alight because there's not that much storage traffic to reduce and optimize and so on. Where we tend to get the most benefit is with things that are more storage intensive. So this tends to be databases like SQL Server, Oracle, MariaDB. As long as it's a database that's running in Windows, we're very likely to be able to help. Also things like busy SharePoint servers, busy file servers, business information systems like IBM Cognos, or ERP systems like Sage. In fact, I wrote a case study with one of our customers who saw the benefits to their Sage ERP system. Pretty much any storage intensive workload, as long as it's running in a Windows environment, is going to get benefit from this. And the reason is that if you think of the movement of your data through your compute environment like a relay race, each component, each layer in the IT stack is like passing the baton from one runner to the next. Your team is only going to be as effective as the slowest runner in that team. And you don't want it to be the way that the Windows operating system sends data out to the storage. It doesn't make sense to invest all that money in the environment and then have Windows slow it down because it's inefficiently interfacing with the storage layer. And that's really where we can help. Right, let's see if we have any other questions. Here we go. Ricardo says, do you have any experience using Velocity on SQL VM machines with a TDE encrypted database? Forgive me, Ricardo, I'm not familiar with TDE encryption, I have to say. So I can't hand on heart say that I do have experience with that. What I can tell you is that our software is not bypassing Windows in any way. It is still the standard Windows write driver creating a standard NTFS storage I/O packet and sending it on down to the storage and so on. So as long as the TDE encryption is compatible with the way that Windows interfaces with the backend storage, it will be compatible with our software. Now, what our software does do is inserts a very thin storage filter driver into the Windows storage stack so that it can help it make better choices about where to start writing on the NTFS volume in order to avoid those split I/O situations. So instead of the Windows write driver having to go back to the Windows free space cache to find another free space extent that isn't big enough, it says, hey, write driver, actually, you've got this data. Start writing at this address on the NTFS volume where there is a large enough area of free space to put that data into without having to split it up, or split it up the least. And so basically what we're doing is we're causing Windows to send these larger packets on down to the storage so that they can be dealt with and written in a far more sequential manner using far fewer storage level operations before that storage transaction can then be acknowledged, and that acknowledgement then sent back up to the stack. So I hope that helps. I'm not personally familiar with TDE encryption, but as long as that is compatible with the way that Windows interfaces with the storage, it will be compatible with our software. Right. So, Pradeep says, what is the price of the license for the software? Okay, great question. Now, as you probably gathered, I'm more of an engineer than a commercial guy, but I can give you some rough ideas. There are several different ways of licensing the software. If you have a requirement for a smaller number of machines, then you can buy it on a per machine basis. So one license is one virtual machine, for example, or one physical machine, and that's about $500 US. I guess it's on the screen there, $524.95. We do offer quantity discounts as well. So if you buy 10 or more, then the unit price will come down. I think there's another price break at 25 licenses, another one at 50, another one at 100, and so on. So basically, the more you buy in one go, the cheaper the software becomes per license or per instance. The more popular way of buying it for a virtualized environment tends to be to buy a host license. And from memory, goodness, don't quote me for this, otherwise the sales guys will will shoot me for this. But from memory, it's about $4,000, I think, for a host-based license. Again, we can provide you with quoting and pricing that's more proper for your environment. But what that basically means is you're licensing a host hypervisor. So let's say you have a VMware ESXi host in your environment, or indeed a number of them, and you license that ESXi host. You don't actually install the software on the host. What it means is that you now have the license to install the software onto as many virtual machines as you have running in that licensed host. And if you spin up new virtual machines, well, they're automatically licensed to run the software too, so you just go ahead and install it. So you can see if you're running more than about 10 VMs in a host, it's actually going to work out cheaper to get a host-based license. So I hope that answers that. Sorry, I can't be more specific, but I am just a lowly engineer, not a sales bot. But the sales guys are very good at helping you or if you describe to them what sort of hardware environment you have, they're very good at working out what is the most economic way for you to consume the software. Right. In a busy SQL server, so this is from A. Jorge Tavares. I'm guessing that maybe Portuguese. Forgive me if I've pronounced that wrong, though. In a busy SQL server, he says, yep. In a busy SQL server, after installing Velocity, it's not necessary to reboot or restart any SQL service, right? Yes, absolutely right. There's zero disruption. You don't have to do anything with SQL after installing the software for it to start work. The only thing that you might want to consider doing if SQL is consuming pretty much all of the available memory and only leaving a few hundred meg free is cap SQL so that it leaves at least 4 gigabytes of RAM free to give us roughly a 1.5, 2 gigabyte cache size. But again, capping SQL, I don't believe that requires a reboot either. If you wanted to add more memory to a virtual machine that's running SQL Server, again, cap SQL so that it can't steal the additional memory that you're adding for itself, and leave enough free for Velocity to cache with. If you do that, it really does help to make that machine fly. And the way to monitor that is just to see how much more work you can get out of that instance if you add just that little bit of additional RAM. And adding additional RAM to get that performance is a hell of a lot cheaper than trying to achieve the same performance gain by upgrading the storage hardware. You know, it's typically a lot cheaper than adding a tray of SSD or flash, or heaven forbid, ripping and replacing the SAN with a much more expensive one. So I hope that answers everything. Pradeep says, I will definitely install and check on my system. Good man. And if you want any help with that, as I mentioned, you're very welcome to reach out and get assistance from me personally. Very happy to help with that. So, we have a few more questions here. If you guys are happy to stay on, I'm happy to answer them. Right. So Jose Costa, I probably should say. I have SQL Server on Windows 10. Should I use Velocity or Diskeeper? That's a great question. I haven't mentioned the sister product to Velocity, really. But yes, Diskeeper is the sister product to Velocity. Actually, it's entirely up to you. Both products do the same job. Really, they have the same feature set. They share a lot of the same code base under the hood, and they do the same thing. So you can run Diskeeper on physical machines or virtual machines, and you can run Velocity on virtual machines and physical machines. So it's entirely up to you. That's helpful if you've got a mixed environment where you've got some physical machines and some virtual. You could, for example, use the Velocity Management Console as your single point of control for all types of Windows machines, regardless of whether they're physical or virtual. So why do we have the two products if they both do the same job and can both be run in the same space? The truthful answer to that is that it's more of a marketing solution. We've had the Diskeeper software for decades now. I think we first brought it out in the early 80s for VAX VMS systems, which I'm sure and hope that most of you are far too young to remember. I unfortunately am not. That's where I started out as well, all those years ago. So people tend to remember the Diskeeper brand as being a defrag solution for physical machines, and it hasn't been that for quite some time now. As hopefully you can gather from this presentation, there's a lot more to it than simple defrag. In fact, you might have seen other presentations that I've done where I've actually said Diskeeper is not a defrag product anymore. It reduces those split IOs for better performance, right the way between server and storage, right the way through the stack, so that everything benefits, and it introduces the RAM caching. So we market Diskeeper really for physical machines because that's what people know the Diskeeper brand as, and we market Velocity for virtual machines. But technically, you can use either software on physical or virtual machines. It's entirely up to you. Uh, Pascal says, will you say that Velocity will improve any kind of T-SQL queries because it reduces or optimizes I/O consumptions? In other words, no need to perform and compare complex comparisons. I'm not quite sure how to answer that. I think you may have stumped me there, Pascal. That's a very good question. This is going to sound like an awful cop-out answer, but I'm afraid my suggestion really is try it and see. Everybody's workload is different, and yes, it will reduce and optimize I/O consumption, but we're talking about storage I/O traffic, not necessarily sort of traffic that is inside the SQL database itself. It's when it comes out and interfaces with that backend storage. So I think it's very likely that we can give you a performance boost, but my best answer that I can give you immediately is simply try it. You're certainly not going to disrupt anything, and the worst thing that can happen is you don't see any performance improvement, and I would give it a few days for that telemetry to work, but if you don't see any performance improvement and you think the software isn't for you, simply uninstall it again. You can do that through Control Panel Add Remove Programs. Again, you're not going to disrupt anything or have to reboot anything when you uninstall it either. So worst case, you've lost a couple of minutes of your time. Best case, we can significantly improve the performance. So it's worth trying. Sorry, I can't be more specific about that. So Jose Costa says 30 days, 106.491 million eliminated IOs. Okay, so I take it, Jose, you've been running it, which is very good, and you've saved storage I/O time of, wow, over an entire day. So that's 24 hours plus another 14.5 hours saved, of storage I/O time saved by the storage not having to process that 106 million IOs that we were able to eliminate. That's very, very good. Mohammed says, have to drop off to join another call. No problem, totally understand. If anybody has to drop off, that's fine. As I say, I am recording this, and the recording, including the Q&A section, will be made available to everybody after the session, so no problem. Sturton says, thank you. You're very welcome. So I think that's all of the questions, and what a great bunch of questions. This is very encouraging. I always love it when I get feedback like this, especially when they are really good, intelligent, technical questions. If nothing else, it means you've been listening, which is great. So I appreciate your attendance. Thank you very much for giving me a bit of your time. Please do try the software. As I say, don't take my word for any of this. Try it for yourself. You really have nothing to lose. And if we can be of any help by answering questions, helping you install and run the software, helping you with a POC, even helping you interpret results, you're very welcome to get in touch. So thank you, everybody. I hope this session's been useful. Have a very good rest of day. Take care.